Greetings. This is Afroz Talukdar from Dhaka, Bangladesh. I'm interested to teach physics, chemistry, and mathematics for grades 9, 10, 11, and 12. For my demo, I've chosen a very interesting topic, atomic models, which is really part of both physics and chemistry. And I'll try to show different aspects of the same. And let's go to the PowerPoint representation, the slides I prepared in this regard. Slide number 1, atomic models. As everybody knows, and we can see on the screen that proton and neutron are the constituents of the nucleus, and electrons are orbiting in shells. That's the fundamental concept. Here we see various spheres. This is a model which was proposed by Dalton, a school teacher. And for example, we see a dot and a circle, which is hydrogen, carbon, which is a dark material, and oxygen, which is really pure white. Copper with the letter C, lead, a circle with letter L, so on and so forth. So here we see the symbolization, which is very important in chemistry. And periodic table, people know that there are about over 100 elements. On the left-hand side of the periodic table, we have the metals, such as group 1, group 2. Group 1 is sodium, lithium to francium. Group 2, we have beryllium, magnesium, calcium. And group 3, we have aluminium. Group 4, we have carbon. Group 5, we have nitrogen. Group 6, we have oxygen. Group 7, we have the halogens, and group 8 are the inert gases. So it's a very important way that Mendeleev described his table. And for his table, he had left some of the places empty. And later on, according to his proposal, these empty slots were filled up. Atomic structure. The plum pudding model proposed by Lord Kelvin and J.J. Thomson. In this model, the overall charge is still neutral, but what happens is the electrons are stuck on the pudding, which is the positive charge, like random plums, as represented here by negative charge. Rutherford's model of atoms. Here, Rutherford, who really had come up with three-dimensional orbital electrons, and he also came up with the orbitization, that is quantization of electrons in shells. Bohr model of an atom is simple as 1, 2, 3, 4. What happens is he represented the K as shell 1, L as shell 2, M shell as 3, N shell as 4th shell. Now, K being the first shell, he proposed the equation and the number of electrons to be found in each shell. If we use the formula, number of electrons, E equals to 2n squared, where n is the number of shells. So K equals to 1, meaning n equals to 1. We square 1, we get 1. In multiply by 2, we get 2. So in K shell, we have 2 electrons. In shell number 2, we have n equals to 2. So number of n squared would be 4, into 2 would be L, 8. L would have 8 electrons. M similarly would have 18 electron for n equals to 3. 3 squared being 9, 2 equals to 18. This is an important diagram which helps us to understand flame test, which many students of chemistry already know. in grade 8 and 9, or even in grade 7. For example, if we go to our mother's kitchen and we see the methane gas burning, CH4 methane gas is represented by CH4, the formula, which is a hydrocarbon, an alkane, basically. Now this alkane, when burned, produces carbon dioxide and water. So it burns with bluish flame. But if you split some salt, then we get a yellowish flame. What happens is very simply explained in this diagram. We see the shell, the flame helped the electron jump to the higher shell. And when the energy got subsided, it went back to its original shell. As a result, a photon of yellow light was emitted, represented here by a red arrow. Now, here we have a very good experiment, which is called the gold foil experiment or the Geiger-Marsden experiment. Gold foil can be beaten into 1 atom thick or few hundred nanometer. That is 1 layer atom or few layers for that matter. Each layer being 1 nanometer. And if we have very thin, we have 1 layer. And the source of alpha particle is basically hydrogen ion. And the source is contained in a lead chamber so that it passes through the foil. In the experiment, the Geiger-Marsden, they observed that out of 100,000 alpha particles, 99,000 would pass through, 990 would deflected through various angles, and only 10 would be reflected back. Rutherford concluded that he stated in his own words, I fired a 16 inches shell on a tissue paper and it came and hit me back. So the conclusion for this experiment, the gold foil experiment, that most of the atom is empty space and nucleus is positively charged, as we now know that the nucleus contains protons, which is positive. And the center, which the nucleus is very massive, as observed by the third conclusion. This is the end of the slides. Thank you for being patient and watching my demo. Hope you liked it.